Hey fifth graders, it's Mrs. Tremblay, and today we're going to actually look at two lessons. We're going to look at lesson 6 and lesson 8, and I'm going to kind of condense them a little bit into one because they're kind of just opposite of one another. So you need your Unit 5 packet opened up to page 8, where at the top it says lesson 6, dividing a decimal value by a whole number, and you need a pencil, please, and you'll be all set. Okay, so we looked at long division already. We looked at that yesterday. I don't know if it's still yesterday when we were watching this, but that's what I did. And we learned how to use a standard algorithm. And today we're going to apply that to decimal values, specifically when you are dividing a decimal value by a whole number. So, mental math to start. It says you have $12.24 to share between two people. How much will each person get? So I want you to press pause and try to figure this one out, and then press play when you're ready. Okay, so in my head, I look at this and think to myself, okay, well, if it's $12.24 and it's shared between two people, we have the dollar part, right? We have $12. So if I shared 12 between two people, that would be 6 each, right? And then if there's 24 cents, if I have to share 24 cents between two people, well, 24 divided by 2, or I could look at the double, what plus itself will give me 24, will be 12. So $6.12 is how much each person would get. And if you wanted to make sure you were right, you could do $6.12 plus $6.12, right? And if you do that, you would get $12.24. Now take a look at letter B. We're going to come back to this in a minute. Letter B says you have $18.75 to share between 3 people. How much will each person get? Again, go ahead and press pause and try to work through this one in your head. You don't have to use a long division strategy. Just think through. You have $18.75. We're sharing it equally between 3 people. Okay, so when I see the $18, I know that the $18 shared between 3 people, 18 divided by 3, that would be 6. And if you have 75 cents shared between 3 people, I see 75 cents as 3 quarters, right? A quarter is each worth 25 cents. So each person would get $6.25. And if I wanted to make sure I was right, I could take $6.25 times 3, or I could add it 3 times, right? Because that's the same thing. Now this last one says it cost $161.12 for 38 sandwiches. How much is each sandwich? So trying to do this one in our head, like thinking to ourselves, okay, 161 shared between 38 or 12 shared between 38. This is a little bit trickier. So we need a strategy, right? We need a pattern. So let's look back here at A and B so you can see kind of what's going on here and we can apply it. So what we did was we took $12.24 and we divided it between 2 people, right? And when you divided $12.24 by 2, you got $6.12, right? So if I took away this decimal point and I gave you this problem yesterday, you would say, well, 2 doesn't go into 1, but 2 goes into 12 6 times. 6 times 2 is 12. And you subtract, and then we bring down. And we'd know that 2 goes into 2 1 time. And we would write down our 2 and subtract, and then we'd bring our 4 down. And we'd say, oh, well, 2 goes into 4 2 times, and 2 times 2 is 4. I'm running out of room. And there's no more digits left to drop. So yesterday you would have gotten 612, right? Well, today there's a decimal point right there. And I'm wondering if you're noticing that it appears that we just divided like normal and kept the decimal point where it was. Doesn't it seem like that's all we have to do? Well, let's test it with letter B and see if that's all we have to do. So if you have $18.75 to share between 3 people, that would mean you're taking $18.75 and dividing by 3. And 3 does not go into 1. You could put your X there if you want. 3 will go into 18, right? 6 times. 3 times 6 is 18. And right now I'm just ignoring that decimal point. I'm going to drop down my 7. I know that 3 times 2 gets me closest to 7. 3 times 2 is 6. And 7 minus 6 is 1. And I drop my 5. And 3 times 5 is 15. And now there's nothing left, right? So it looks like 625. You see our answer is 6.25. 0.25, right? Well, if I keep my decimal right where it is, that's what I get. Okay, so if we use this little rule here, how could we figure out the cost of each sandwich if it's $161.12 for 38? Well, we can take $161.12 and divide it by 38. And I'm hoping that you're seeing that we can just solve this like normal and keep our decimal point where it's at. So 38 will not go into 1. 38 will not go into 16. And now we have to guess, how many times would 38 go into 161? So I would round this to the nearest 10 and call it 40. And I would ask myself, the 4 in 40 times what gets me closest to 16? Well, 4 times 4 is 16, right? So that means that 40 times 4 would be 160, which is really close to 161. So I would try 4. And notice I'm putting it right above the 1 because I'm dividing 38 into 161 and need that 4 in the 1's place. Okay, so I'm going to take 38 times 4 to see what to write underneath. 8 times 4 is 32. 4 times 3 is 12, 13, 14, 15. We get 152. All lined up with the 161. And we go ahead and subtract. I need to borrow from the 6. 11 minus 2 is 9, and then 0, 0. So 9 is less than 38. I know we chose right. I'm going to go ahead and drop down this 1. So now I can see 38 into 1,611, technically. So how many times do you think 38 would go into 91? Well, 38's close to 40, right? I could only fit 2 40s into 91. So I'm going to write my 2 right above this 1 because that was my final digit. And now I need to take 38 times 2 to see what to write underneath. 8 times 2 is 16. 2 times 3 is 6 plus 1 is 7. I get 76. And I need to borrow. 11 minus 6 is 5. 8 minus 7 is 1. We're not done because there's still a 2 right there. And now I need to figure out how many times will 38 go into 152. Well, I don't know if you noticed, but 38 times 4 is exactly 152. We already did that, right? So I'm going to put a 4 right here, and I know that it's 152. Now there's nothing left. So in looking at this, let's think about this, about where the decimal would go. If it's $161.12 for 38 sandwiches, would it make sense that one sandwich is $424? No. Would it make sense that one sandwich was $42.40? $42 for one sandwich? There's no way that I could get 38 sandwiches for $161. So that wouldn't work. Would it make sense that each sandwich is, if I rounded this, 43 cents? No, that would be way too low. So the only logical place for this decimal to go is right between the 4 and the 2, which just so happens to be where it already was in the problem. So the answer to this one is $4.24, which is pretty reasonable for a sandwich, I think. So what's the pattern? Like, what are we doing here when you see that you have a decimal value? You're dividing a decimal value by a whole number. See, this decimal value, this whole number. Well, what's happening is we're dividing normally. And keep the decimal where it is. All right, so that's lesson 6. So let's try a couple of these problems, okay? Here we go. So when I see this problem, I see a whole number and I'm dividing it into a decimal, right? And we just saw when that happens, I can keep the decimal right where it's at and divide normally. So I would actually put my decimal right there to start. That way I wouldn't forget it, because I used to forget them. I know it's hard to believe, but I would do all the work and I'd forget the decimal point and get the answer wrong, and that is frustrating. So now we're going to go through like normal. 8 will not go into 4. This is like what we did yesterday. 8 will go into 47, and 8 times 5 will get me closest to 47. 8 times 5 is 40. And there are 7 left over. So I know I picked right because 7 is less than 8. Now I need to drop down my 6 and ask myself 8 times what gets me closest to 76? Well, 8 times 9 is 72. And 76 minus 72 is 4, and that's less than 8, so we're good. I drop down my 8. 8 times 6 is 48. And voila, there's nothing left to drop. Our answer would be 5 and 96 hundredths, 5.96. All right, why don't you try letter B and then press pause and then stop, when you're done, press play. All right, welcome back. I'm going to put my decimal point where it goes. 9 will not go into 5. 9 will go into 58. I know that 9 times 6 is 54. And after you subtract, you should have 4 left, which is less than 9, so we're good. Next digit is a 6. So 9 will go into 46. I know that 9 times 5 is 45. And there's 1 left. And I drop down my 8. And 9 times 2 is 18. And now there's nothing left. So your correct answer would be 6 and 52 hundredths. Okay, we're going to skip letter C for now. And I just want to do a couple here. Oh, my division signs got moved around on this. I don't know how that happened. Well, let's look at letter G. I want you to practice this when we have a double-digit divisor. Okay, so we're going to do letter G. 78. First off, see this decimal point? I'm going to put it right where it goes because it's a whole number divided into a decimal. If there's a decimal value on the inside and a whole number on the outside, all you need to do is bring up your decimal point and divide like normal. If you're feeling good about it, press pause and then press play to see if you're right. 78 will not go into 7. 78 will not go into 70 either. And I have to try to figure out, okay, 78 will go into 706 how many times? Well, I would look at 78 like 80, right? And I would ask myself, 8 times what gets me closest to 70? So I know that 8 times 8 is 64. We said that 8 times 9 is 72, right? So it's either going to be 8 or it's going to be 9. Now I know this is less than 80, so I'm going to try 9. And off to the side, I need to go ahead and actually do 78 times 9. So 78 times 9. 9 times 8 is 72. 9 times 7 is 63, plus 7 is 70. So I just got 702, which is super duper close to 706 without going over. That's great. And 6 minus 2 is 4, and 4 is less than 78. So we can keep on going. I'm going to drop this down, and I get 46. Okay, now you might be like, wait, 46 is less than 70. What am I supposed to do? What do I do? Well, how many times will 78 go into 46? We repeat the same process. 78 goes into 46 0 times. And 78 times 0 is 0. And there's still 46 left over, and I drop my 8. I know, it's crazy, but I need to have a 0 in that placeholder. That means this answer has 0 tenths. Now I need to ask myself, how many times will 78 go into 468? I could ask myself, 8, if I round this to 80, times what gets me closest to 46? So I know that 8 times 5 is 40, and this is less than 80. So instead of 5, I would personally try 6. If you try 5, you're going to get something that is too low. You'll know because your remainder is more than 78. So go with the 6th, okay? 78 times 6. 6 times 8 is 48. And 7 times 6 is 42 plus 4 is 46. We get exactly 468. And we're set. $9.06 if it was money, or just 9.06, 9 600ths. So hopefully you're getting the gist of this right now, that all you have to do if you are dividing a decimal value by a whole number is do exactly what we did yesterday, the standard algorithm, but bring your decimal point up and keep it right where it's at. Okay, we're not done. If you need a break, you can press pause before moving on to the next thing. But I want us to look at lesson 8. So if you took a break, welcome back. I need you to go to page 11 in your packet. And this is lesson 8, dividing whole numbers by decimals. So in the other problems that we did, it was a decimal divided by a whole number. Today, it's going to be a whole number divided by a decimal. Well, I guess it's not really a separate day, but we're doing both of them in one day. Because it is crunch time, right? Yeah, honestly, it's because I think you can handle both of them in one day. Otherwise, I wouldn't do it. Okay, we're going to skip these sections up here and hop right down to the problems, just the examples. I think the examples will really be helpful here. And you're actually going to use the idea of equivalent fractions to help you understand what you're doing here, okay? So if you have 1/2, this actually does mean 1 divided by 2, right? Yes. And I could create a bunch of equivalent fractions here. I could multiply them both by 10, and I'd have 10/20ths. I could multiply both by 100 and have 100/200ths. I could multiply them both by 1,000 and have 1,000/2,000. Every single one of these is equal to 1/2, right? Every single one of them. We learned that when you see all these zeros, this is like saying 10 divided by 10, so those would cancel out, cancel out, cancel out, there's a half. Cancel out, there's a half. Cancel out, there's a half, right? So these zeros here, it's like canceling out 10 divided by 10. Now this looks a little bit strange, doesn't it? You haven't seen anything like this? If it looks strange to you, it could be because you know that you're not supposed to have a fraction with a decimal in it. It's not allowed. You'll learn that especially in 7th grade. So what we can do here is, to get rid of this decimal, let's multiply both of these by 10, right? Multiplying them both by the same thing creates an equivalent fraction. So if I do 2 times 10, 2 times 10 is 20. What's 5/10 times 10? Well, you learn that when you multiply by 10, you can shift the decimal one place to the right, right? So that would be 20/5. All right, let's try it with 100. If you do 2 times 100, that would be 200. And if you do 5/10 times 100, that would mean I'd have to move it twice. So it would be 200/50. And if we did it by 1,000, 2 times 1,000 is 2,000. If you take 5/10 times 1,000, that would mean 1, 2, 3 moves, which would give me 500. Now, every single one of these, if we figured them out, what's 20 divided by 5? Well, 20 divided by 5 is 4, right? So this is equal to 4. If you do 200 divided by 50, you can actually cancel out, or do 10 divided by 10, right? And we've already learned that, so I'm not going to do a mini lesson on it right now. Maybe in class I will. But it's still 20 divided by 5, which is 4. And if I eliminate those by doing 10 divided by 10, 10 divided by 10, it's still 20 divided by 5, which is 4. Those are all equivalent. So what I'm hoping you're seeing with this is if you multiply both digits by the same thing in a division problem, because this means 2 divided by 5/10, okay? If you multiply both values by the same thing, you create an equivalent division problem that will give you the same answer, which is exactly what we do for these, okay? So this is different than the previous lesson because I don't have a decimal inside here. I have one on the outside. My divisor is a decimal. And instead of figuring out how many 5/10 go into 6, what we can do is we can create an equivalent division problem that allows us to do this without the decimal values, which it's a lot easier to look at this as 20 divided by 5 instead of 2 divided by 5/10. But you can see those all have the same exact value of it. So when you see that you have a decimal divisor, all you have to do is shift the decimal point or multiply by 10 the same number of times to get rid of that decimal point. And if you're like, I don't know what you were talking about, Mrs. Trombley, let me show you. So here, I don't want it to be 5/10, right? I want this to be 5, just like I wanted this to be 5. And in order for this to be 5, wouldn't I have to multiply it by 10? Yeah, because multiplying by 10 shifts it one place over. So then I could make this a 5. But in order to have an equivalent equation that will give me the same answer, I can't just multiply that by 10. I have to multiply the other by 10 as well. So if you do 6 times 10, that means I'm shifting one place to the right, and you know 6 times 10 is 60. So 60 divided by 5 is the same as 6 divided by 5/10. It's just like this. We multiplied them both by 10 to create an equivalent equation. And now you can just divide. Maybe you know that 5 times 12 is 60 off the top of your head and get an answer of 12. Or you say, well, 5 does go into 6 one time, 1 left over. 5 goes into 10 twice, nothing left over. No more digits left to drop. So 6 divided by 5/10 is 12. And if you think about it, 0.5 is half, right? Don't 2 halves make 1 whole? So if you have 6, that would be made up of 12 halves. That's what this problem is saying. All right, for letter B, I don't want it to be 36 divided by 9/10. I want this to be a regular 9. So that means I multiply this by 10 and that by 10. If you do that, you create equivalent equation. So I'm going to have 9 into, not 36, 9 into 360. 9 won't go into 3. It will go into 36 4 times. 9 times 4 is 36. There's nothing left. I still have this 0 though. And 9 goes into 0 0 times. Nothing left to drop. Our answer is 40. For letter C, I don't want this to be 7/10. I want it to be 7. So I move it one place right. I have to move that one place right. So I'm really taking 7 into 140 because that's equivalent. 7 goes into 14 twice. And I'm bringing down my 0. 7 goes into 0 0 times. So 20 would be my answer. And 7 times 20 is 140, so we know we're good. Okay, for letter D, in this one, to make it 5, I would have to move it 2 places to the right. That means I need to move this 2 places to the right. So this is actually 5 into 3,500. And 5 times 7 is 35. I'm wondering if you're noticing that when you have these zeros here that it ends up just being 0. I would be okay if at this point when there's only zeros left, if you just wrote in the 2 for the places. If that's not making sense to you, then drop your 0 and 5 goes into 0 0 times. And drop your 0 and 5 goes into 0 0 times. So 700. Okay, these ones I wrote differently because I wanted to make sure that if you saw this, you would know what it meant. So this is 4 divided by 800ths. What this looks like is 4 divided by 800ths. So when you see it written like this first number tells you your dividend. This tells you what you're dividing by, so it's flipped. So if you saw something like this, I would expect you to rewrite it like this. And here, I have to move my decimal point 2 places to the right, so I'd move this 2 places to the right. So I'm taking 8 into 400. 8 won't go into 4. It will go into 40 5 times. 8 times 5 is 40, nothing left. I bring down my next 0, or again, if you notice, oh, these are all zeros, you can just fill in. I'm okay with that. 50 is your answer. Okay, I want you to jump down to letter H. 42 divided by 7 thousandths. So if it's 42 divided by 7 thousandths, that means that 42 is inside. This is my dividend. My divisor is what I'm dividing by. That goes outside. It does matter, right? There's not a commutative property of division. So here, 1, 2, 3 places I'd have to move it. That means I'd have to move this 1, 2, 3 places. So 42,000 divided by 7 will give me the same answer as 42 divided by 7 thousandths. They are equivalent. We saw why right up here. So 7 times 6 is 42. And do you see how I have 3 zeros left? That means I'm going to have 0, 0, 0. 6,000. That's the pattern that's taken place. All right, you did it. 2 lessons in one day. Congrats. I hope you enjoy practicing your riddle sheets.